Hi everyone, welcome to another video of calculus. In this video, I'm going to explain linear approximation and linearization. Linear approximation is a concept that we can use to approximate values of functions when we know uh, a value of function at a certain uh, x value. For example, we know the cubic root of 8 is equal to 2. But we cannot directly find the cubic root of 8.1 without a calculator. Now, through the concept that we learn in linear approximation and also with linearization, we would be able to find uh, the root of this value uh, by taking the linear approximation of function f of x to the power 1/3. And another example, we know that f of x, if you're given f of x sine x, we can find f of pi over 3. That means uh, sine 60, sine pi over 3, which is equal to square root of 3 over 2. Now, by knowing that value, we should be able to find sine uh, f of pi over 3 uh, plus zero point 0.1 or sine pi over 3 plus zero point 0.1, which cannot be easily find uh, without using a calculator. You need a calculator. But by using linear approximation, we will be able to find those type of values without using a calculator. So what is this linearization? So why is this a, a, a problem in calculus? Well, we're going to use the knowledge of calculus to linearize functions. Actually, we already know, you already know what I'm going to talk about, because we know that if we have a function of f of x, uh, curve like that, I can draw a tangent at a given point. Let's say this is a known point A at a given point. If I draw a tangent right here, the slope of the tangent is at that point is f prime A. Now, when I'm asked to find the value of the function right here, that means let's say this distance is delta x, I can find that is a plus delta x. So this function value here is f of a plus delta x, and this is actually f of a, right? And I can I can write that delta f is equal to f of a plus delta x minus f of a. And by the definition of f prime a, I can write limit delta x going to 0, f of a plus delta x minus f of a divided by delta x, which is again limit delta x going to 0, delta f over delta x. Now, when delta x is very small, when delta x is very small, we can approximate that. Uh, delta f over delta x is equal to f prime of a, right? That means when x goes to 0, when x is very, very small, that means it's right there, right? That's what this limit says. When limit goes to 0, delta x goes to 0, when that delta x is very, very small, right? Delta f over delta x is equal to approximately equal to f prime of a. So we can find delta f by using f prime of a times delta x. F prime of a times delta x. Now, let's try to use this knowledge in our one of our previous questions. So you know that we need to find the square root of 8.1, and we know that cubic root of 8 is equal to 2. We need to find cubic root of 8.1. So if you draw the function of cube, uh, x cube, right? It's something look like that. So that is f of x. This is x. And we exactly know that at 8 it is 2, right? And then 8.1 is pretty close to that. 8.1, we can approximate the function f of x is equal to x to the power 1/3. So we can find f prime of x equal to 1/3 is equal to d over dx. This is where we use calculus. 1/3, that is 1/3 x to the power 1/3 minus 1, 1/3 times x to the power negative 2/3. So f prime of a, or f prime of 8, f prime of 8 is equal to 1/3 x to the power, that means 8 to the power uh, 1/3. This is 1 over 8 squared, the cubic root, right? Cubic root of that. That's f prime of 8. So we can find, if you take delta x, if you take delta x is equal to 0.1, we can find, I'm going to write it here, we can find uh, delta f is equal to, roughly equal to, f prime of a times delta x. So, and that means f of 8.1 minus f of 8 equals f prime of 8 times 8.1 minus 8. Okay, so what we are looking at is finding this. So now we can write f of 8.1 equals f of 8 is 8 to the power 1/3 plus this is 1/3 times 1 over 8 squared, square root of cubic root, and then this part is 0.1. So this is 2 plus 1/3, and that is equal to 4, right? 4, 1 over 4 times 0.1. So you're going to end up with 2 plus 0.1 divided by 12. So that answer is going to be uh, the answer is going to be 2 plus zero point 0.1 over 12 is 0.1 divided by 12 is equal to 0.008333. So it gives me 2.00833. That's F 8.1. So, and then if you find the F of 8.1 using a calculator, uh, it's going to be 2.00829, something like that. That's pretty close to what we got, 0.8833. So this is the calculator value. So this can be done for any function. This can be done for any function. So all you need to know is if you know to find delta f, which is also equal to f of a plus delta x minus f of a, which is equal to approximately equal to f prime of a delta x when delta x is very small. So that's what the linear approximation. If I show you this graphically again, so this is the graph, and this is uh, the tangent line, and that's the a plus delta x, and this is a, and this is f of a. This is f of a plus delta x. This is what we need to find. But actually, with that approximation, we find this value. This is delta x. This is f prime of a times delta x. This way, right here. So that's the one that we actually find as the change. This is actually this approximated value. Okay. So that's how we can. That's how it is graphically shown. And also we know that, so if I draw again this graph, I can show you that we can obtain a linear function for any function of f of x, linearized function for any function of f of x. Uh, for example, you have a curve of f of x, curve of f of x. We have here at this point, I'm going to draw a tangent line. Okay, I have to draw another line, tangent line for this function. See at this point, a tangent line, and the function of the tangent line we have obtained it previously. The function of tangent line is equal to f of x equals f prime of a, if this is a, times x minus a, right, time plus f of a. That's the function of the tangent line. So in the neighborhood of this x equal a, at the neighborhood of x equal a, actually if I zoom in to that place right here, if I zoom in here, I can see that in the close proximity of that point A, the function looks pretty, if this is A, it's pretty close to this x equal A, it's pretty close to the real actual function. The tangent line is very close to the actual function. So we can, at the neighborhood of A, we can at the pretty at the very close to A, we can assume that this, in the very close values of A, we can assume that this function, uh, the function can be approximated uh, by the equation of the tangent line. So f is f if f is differentiable at x equal a and x is close to a, then fx is equal to f of a plus f prime of a times x minus a. That's our approximation. That's a linearized function. We can linearize any function by using this, by using the function of the uh, tangent line or equation of the tangent line. Uh, so the example, determine the linearized formula for f of x equal square root of x times e to the power x minus 1. Now f of x, the linearized form is equal to f of a, and this is at x equal 1 plus f prime of a x minus a times x minus a. So f of a is equal to square root of 1 times e to the power 1 minus 1 plus f prime of a. So f prime of x is equal to uh, square root of x times d over dx e to the power x minus 1 plus e to the power x minus 1 times d over dx square root of x. So this is square root of x times e to the power x minus 1 plus times 1. You have to find d over dx e to the power d to dx d over dx x minus 1 plus e to the power x minus 1 times half x to the power minus half, right? So this is square root of x e to the power x minus 1 times 1 plus e to the power x minus 1 half square root of x. So if we take e to the power x minus 1 out, we get square root of x plus 1 over 2 times x square root of x. So f prime of a is equal to e to the power 1 minus 1 plus 1 plus 1 over 2 square root of 1. And then this is x minus 1. So we have um, e to the power 0, that is equal to 1. So that's equal to 1 plus uh, this term right here is equal to 1, and this is half. So 1 and half is 3 halves. So you have 3 halves is x minus 1. That's your linearized function. So you'll get a linear function always. You should get a linear function for that. So we can approximate square root of x e to the power x minus 1 as a linear function of 3 over 2 x minus half. So that's our linear function. So you can find any value close to x plus 1 by using uh, this equation on the right hand side, and you'll get a very good approximation for that. So you can also find the error. The error is equal to error in this approximation is equal to uh, the error is equal to error is equal to delta f. That's the actual value change minus the approximated change f prime of a delta x, right? Let's see. This is the actual. This is the approximated change. It's called error, right? And sometimes in differential calculus, in calculus, you can put delta f approximate equal to f prime of a delta x, and this is actually delta f is equal to delta y, right? And that's equal to f prime of a delta x. If you write in differential terms, it's going to be dy is equal to dy is equal to f prime of a dx. So that's called the differential form. That's called the differential form. It's the same thing in a different name. Actually, this is equal to roughly equal to delta y, approximately equal to delta y. Right. So let's work out some problems. Uh, Example, estimate tangent pi over 4 plus 0.02 and compute percentage error. So if I define f of x as tangent x and at a equals pi over 4, we can linearize it. To linearize this, you need to find uh, f prime of x, which is equal to secant squared x, secant squared x. So linearized function is f of x, which is equal to uh, f prime of a, that given input, x minus a plus f of a. So here a is equal to pi over 4. So f of a is equal to tangent pi over 4, which is equal to 1. And then f prime of a is equal to secant squared pi over 4. Secant pi over 4 is square root of 2. And if you get the square of that, it is equal to 2. Now we can approximate linearized function f of x. F of a is 2 plus f prime of a is, sorry, f of a is 1. 1 plus 2 x minus 1. So you get 2x minus 1 is f of x, right? So this is an approximation for tangent x, 2x minus 1, approximation for tangent x at the vicinity of x equal a equals pi over 4. It might change at another point. Mm, oh, actually, I need to put that as pi over 4. Pi over 4. So this is, I need to put that 2x plus 1 minus pi over 2. Pi over 2. Uh, so we need to find tan pi over 4 plus 0.002. That is equal to f of pi over 4 plus 0.002, which is equal to 2 times uh, 2 times x is equal to now uh, pi over 4 plus 0.002 plus 1 minus pi over 2. So we have pi over 2 plus 0.004 plus 1 minus pi over 2. That cancels this, and then it's going to be point 1.004 1.004 1.004. So the percentage error, uh, the calculator value should be 0.02, not 0.002. 0.02. Percentage error. The error divided by actual value times 100. The error is actual value minus approximated value divided by actual value 100. So the calculator value is actual value 1.0408. The approximated value is 1.04 divided by actual value 0.0408 times 100, which is equal to 0.08%. So very low percentage of error for that easy approximation. Um, so we can approximate any function by using that at the neighborhood of the given points, and then we can get the values get the value of any x value. Um, so we can work out some problems. Um, let's take this problem. For problem 9. F of x equal 1 plus x. Estimate delta f using a equals 3 and for delta x equals 0.2. So delta f, which is also equal to f of a plus delta x minus f of a equal to delta equal to f of a x minus a, or you can put delta x f prime of a. So f of a plus delta x equal to f of a plus f prime of a delta x. F prime of x equal to d over dx 1 plus x to the power half is equal to half times 1 plus x to the power negative half, and then d over dx, the derivative of this one, 1 plus x that is 1. So you have 1 over 2 times square root of x plus 1. That's f prime of a. So you can find uh, f prime of a is 3, delta x is 0.2, equal to uh, approximately equal to f of 3 plus f prime of 3 times 3, uh, the delta x is 0.2 times 0.2. So f of 3 is 1 plus 3 plus f prime of 3 is 1 over 2, 3 plus 1 times 0.2. So this is 4, square root of 4 is 2, plus 1 over 2, square root of 4 is another 2, times 0.2. So I can write 0.2 here, 0.2 here. So 2 plus 0.05. So it's going to be 2.05. That's f prime, sorry, f of 3.2, right? F of 3.2. That's how you approximate one value. So then we can use linearization. So find linearization of f of x equals sine squared x at a equals pi over 4, and find f of 1.1 pi over 4. So we can find the linearization equation is f of x can be approximated by f of a plus f prime of x times x minus a, right? This is how we're gonna approximate the function, right? F of x is approximated by this at x equal a. So now for this function, f of a is equal to sine squared pi over 4, right? Sine pi over 4 is 1 over square root of 2, that's squared, which is equal to half. And then I can find f prime of x, which is 2 times sine x d over dx sine x, which is 2 times sine x cosine x, right? And then x a, and then I can find the linearized function f of x is equal to f of a is half plus f prime of x, that is 2 sine x cosine x times x minus pi over 4, right? X minus pi over 4. Then I want to find, by using this linearized function, I want to find f of 1.1 pi over 4, which is approximately equal to half plus 2 times sine x, actually sine 2x. This is, I can write as half plus sine 2x times x minus pi over 4. Sine 2x. 2x is 1.1, 2.2 pi over 4, right? Sine 2x. X is equal to 1.1 pi over 4 minus pi over 4. So we have half, this 2 is not there because sine 2x, we took sine 2x, plus sine, uh, it's 5.5, 0.55. So sine 0.55 pi times 0.1 pi over 4, right? So when you solve that part of the equation, you can get the answer for that equation. So you can get any function like that and then linearize it and then find the values of the function at any given point close to the function where you linearized it. Well, with that, I will conclude this video. If you have any questions, please ask later.